Alrighty, good people. Here's the last example in this section of completing the square and long division as a way to simplify an integrand in order to take an antiderivative. On number 5, as we're looking at it here, this is not top heavy, this is bottom heavy. Not only that, the bottom, the denominator, is quadratic. So maybe we can complete the square. So I'm going to try to complete the square. So x squared minus 4x plus 20. I'm going to group the first two terms. It's a positive x squared, so I can continue going. I'm going to take the middle coefficient, that would be the negative 4, and I'm going to cut it in half, so divide it by 2, and then square it. So if I take negative 4 and divide it in half, so that'd be negative 2, and then square it, that'd be positive 4. So I'm going to add 4. But if I add 4 on the inside of the parentheses, if I introduce this plus 4, I can't just willy-nilly let it go. I got to compensate it with a minus 4. So I added 4 here, and I'm going to subtract 4 on the outside. And that way, this expression is the same as the original one. However, now inside of the red parentheses, I can factor that out into x minus 2 squared plus, and on the outside, I'm going to get 16. Awesome. Here we go. So this is equal to 32 over x minus 2 squared plus 16 dx. Now, this kind of reminds me of arctangent, except I need this to be 1. And this 32 also is kind of randomly there in the way. So how do we get around that? Well, if the arctangent, this, again, I want to point out, the format of this is almost what I need, except I need 16 to be a 1, right? It's u squared plus 1 in the denominator. So what I'm going to do is I'm going to divide this term by 16, but if I do that, I need to divide this term by 16, and I need to divide that term by 16. So everyone's going to get divided by 16. So it'll look something like this. Divide by 16, x minus 2 squared divided by 16, plus 16 divided by 16. Now, in your head, you can probably do this. You don't have to show it. But I wanted to show you how I'm going from here to the next step, which is going to be 2 over x, well, let me do this part, plus 1, right, which is what I wanted. And then here, I noticed that the top is a square, but the bottom is a square as well. So why don't I just write this as x minus 2 over 4 squared dx here. All right, let's double check what if we understood how that happened. X minus 2 squared, x minus 2 squared, and then on the denominator, 4 squared. Oh, that's where that 16 is. But now, here's where we can take it to the next level. I'm going to pull this 2 to the front, and that's going to leave me with 1. And I'm going to use u substitution with the inside of the parentheses. That means du would have to be 1/4 dx. Do I have a 1/4 dx? I don't. So I'm going to multiply this by 1/4. But if I do that, I got to divide by a fourth, which is the same thing as multiplying it by 4. Okay, so I took the derivative of this and I got 1/4. I didn't have 1/4 dx, so I multiplied 1 by 1/4, so I can get 1/4 dx, and I'm going to be able to replace that with du now. And then the inside of the parentheses is this, so that's going to be u squared plus 1. But because I multiply by 1/4, I got to divide this by 1/4, which is the same thing as multiplying it by 4, by just 4. And that's going to give me 8 in the outer part of the integral. Now I have what I need. I have the setup for arctangent. So this is 8 times tangent inverse, or arctangent, of u plus c. But since we were in the world of x's, this would be this of x minus 2 over 4 plus c. So as we finish this last example, I want to let you know this is not something you'll be doing a lot, but I do need you to have these, I call them kind of like techniques or sleight of hand tricks that can help rewrite something, make it look like something familiar so that we can find the antiderivative. That was the goal of 6.10, is reminding you how to use long division and completing the square to rewrite the integrand, which is an irrational expression, into something that is more workable.